Good afternoon, children. Today we are going to start with equilibrium part 1, and in this lecture we are going to discuss the PYQs of NEET based on equilibrium. And what equilibrium are we going to see? We know that there are two kinds of equilibrium. One is an ionic equilibrium and other is your chemical equilibrium. So in this lecture we are going to focus only on chemical equilibrium. In the upcoming or the forthcoming lectures we'll see the ionic equilibrium. Okay, so you all know what you're supposed to do. You're supposed to pause the video for a second or for a minute, and you have to at least figure out the way how to approach these questions. Okay, so let us begin. So before starting, we'll just see what equilibrium means, right? Suppose A is reactant and it's giving B as product. Yeah, A is your reactant and B is your product. Initially, A is completely converting towards B, right? Okay, we're getting only products, but there comes a stage. There comes a stage when the rate of forward reaction equals the rate of backward reaction, and that stage is called as your equilibrium, and that stage is called as the equilibrium, right? I hope we all know these things, and at least you would have covered the basics of equilibrium so that we can discuss the concepts here. Okay, so let us go ahead and see. So the first question on your screen, everyone needs to pause it and try it. Okay, children, let us see what is given here. Suppose a reaction is given to us where 2A plus B give rise to 3C. Okay, a general reaction is given to us in this manner, and we are supposed to find out the equilibrium constant. What equilibrium constant? So what are we going to do? We are going to take the concentration of products divided by concentration of reactants. Yes, so we are going to take the concentration of products divided by the concentration of reactants. When we take the products or reactants, we will consider only those which are in gaseous state or in aqueous state. Yes, we will ignore those which are in your solid state. Their concentration terms are not taken, okay, while calculating the equilibrium constant. So consider all of these are in aqueous state, so their K will be equals to C raised to the power 3 divided by A raised to the power 2 and B raised to the power 1. So we saw that we are taking the concentration terms here with these powers which raised to some powers, and these powers are nothing but the stoichiometric coefficient. Yeah, the powers are nothing but stoichiometric coefficients. Yes, this is how we calculate equilibrium. When we talk about equilibrium constants, there are two types of equilibrium constant. One is your Kc, another is your Kp. Yes, Kc is generally the concentration terms when the concentration is expressed in terms of molarities. Kp is for gaseous concentrations. Okay, here we take the partial pressures. In general, we take the partial pressures, okay, for gases, right? Okay, so this is Kc and Kp. Now is there any relationship between Kc and Kp? That is what we are going to see. So what is the relationship between Kc and Kp, children? Kp is equal to Kc into RT to the power delta Ng. This is the relationship between Kc and Kp. Yeah. Now what is this delta Ng? That we will discuss. As we see here, Ng is written, so we are going to consider the number of moles. N is nothing but the number of moles of gaseous reactant and product. Yes, number of moles for gaseous reactants and products. Now, talking about delta N. So what is going to be your delta N, children? Delta N is the number of gaseous moles of products minus the number of gaseous moles of reactants. Yes, this is your delta Ng, children. Okay, so what delta N is the number of moles of gaseous products minus the number of gaseous moles of reactants. So that is the relationship between Kc and Kp. We are not going to forget this. This is very, very important. Okay, so Kp equals to Kc into RT to the power delta Ng. I hope you all understood this concept. Now we'll see what is given in the question and what concept is being used. We'll see. What is given here? Kp for the following reaction is 3. So the value of Kp is given to us. Kp is equal to 3.0 and the temperature is given to us, that is 1000 Kelvin. Yes, it is given to us as 1000 Kelvin. Then it is given to us as a reaction is given to us and the reaction is CO2 plus C give rise to 2CO. As we can see, all the gases, only one of them is in solid state, that is your carbon is in solid state. Yes, and rest of them are in gaseous state. So while considering the equilibrium, we are going to consider only these things because they are in gaseous state. This has to be ignored. This is going to be ignored. What will be the value of Kc? So we are having the value of Kp. We are being asked the value of Kc and the value of R is also given to us. 0.083 is given to us. Yes, children. Now we are given with Kp and we are asked Kc. So now we understood that the relationship between Kc and Kp is going to be discussed here, right? So Kp equals to Kc RT delta Ng, right? So if we see delta N here, so what is going to be your delta N, children? Delta Ng, because we are considering only the gaseous moles. This is 2 here and this is 1 here. We are going to ignore this. Yes, we are going to ignore this. So what is going to be your delta Ng, children? Your delta Ng is going to be 2 minus 1. That is going to be 1. Yeah. So Kp is given to you as 3 equals to Kc into RT to the power 1. It is RT to the power 1. Yes or no, children? Now, will you erase rest of the things? Okay. And what do we see here, children? 3 equals to Kc into the value of R is 0.083 into temperature is 1000. Yes. So 3 equals to Kc into 83, which implies Kc equals to 3 by 83. Okay, 3 by 83. So if you do this, you are going to get 3 and 83. So this is 0. You get here, you get one more 0. So you get 0. This is going to be 4 times. If you do, you're going to get 32. Yes, if you are going to do 3 times, okay, this is 9 and this is 249, right? So 3s are 249 you are going to get. And this is your 1 and this is 5. So this is 0 again. So if you do 6 so you're going to get, right, 6 So 0.036 is going to be your answer. Yes, your answer is answer is your 0.036. If I write it in the standard form, there will be a point after the digit, like point after 3. So if I write it 3.6, then we have to write 10 to the power minus 2. 10 to the power minus 2, right? So that is in which option, children? That is in option number C. That is an option number C. So that is going to be your answer. Yes. Okay. I hope everyone understood how to solve this and how to do this. Yes. So we understood what is the relationship between Kc and Kp and how to solve this. I hope you can do such type of questions. Okay. Let us move on to the next question and see what's there for us. Okay. Now everyone needs to pause it again and try it. Yes. Okay. Okay, children. Time up. Let's see what's given in the question. The question is given that we have been given an equation, and the equation is 3O2 is in equilibrium with 2O3, both are in gaseous state. Okay, then what is being given to us here? Let us see. It is given that, just a minute, children. For the above reaction at 298 Kelvin, Kc is found out to be this much. So the value of Kc is given to us, and what is the value? Kc equals to 3.0 into 10 to the power minus 59. If the concentration of O2 is at equilibrium, the concentration of O2 is given to us, which is 0.040 m, molarity is given. You have to find out the concentration of O3. You have to find out the concentration of O3, right? So if you find out the concentration of O3, let us see what are we going to get. So now, which formula are we going to apply here? We have been given Kc. Yes, we have been given Kc, and we know what is the formula of Kc. Kc is the concentration of product raised to some power divided by concentration of reactant raised to some power, which are nothing but their stoichiometric coefficients, right? Yes. So if we write down here, then Kc will be equals to P is O3, concentration of O3 raised to the power 2, divided by, this is O2 raised to the power 3. Yes. Now we'll substitute the values that are being given to us. Kc is being given to us as 3.0 into 10 to the power minus 59. The value of O3 is not known to us, so we'll take it O3 square. O2 is given to us as 0.040, or I'll take it as 0.04 cube, right? We'll take it like this. Now if I take it like this, so can I write it, or we'll take it 0 only? Okay, so if I write it like this, then what is going to be the answer, children? This is 3 into 10 to the power minus 59 is equal to concentration of O3 square divided by, so we know that 4 4s are 16, 16 4s are is 64, 16 4s are 64, right? 16 4s are 64, and you have to put a point before how many digits? Before 9 digits, right? Before 9 digits. Yes. So it is only 2 0 0 0 0 0 0 1 2 3 4 5 6 7 8 9. Okay, this is like this, right? Okay, now if I want the point this side, so I have to write into 10 to the power minus 9. Yes, so I can write it this way. This I can write is 64 into 10 to the power minus 9. 1 2 3 4 5 6 7 8 9. Yes, 10 to the power minus 9. Now when this goes this side, it is going to be multiplied, right, children? Yes, so if I multiply it now, this is going to be 3 into 10 to the power minus 59 into 64 into 10 to the power minus 9 is equal to O3 square. Yes, can I write it like this? Yes, if I write it like this, so this will be 3 into 64 into 10 to the power minus 68. Yes, 10 to the power minus 68. Now children, we have to find out, if we want to find out only O2, I have to do the square root. Okay, but this is 68 here, right? So if you're doing it half of this, so this is going to be O3 square. Okay, now what I'm going to do, I'll make this 64. How am I going to make this 64? I'll multiply 10 to the power 4. Yes, and I'll also divide it with 10 to the power 4. Then I'll get above, I'm going to get 3 fours are 12, 3 fours are 12, and 1 18, 18 and 19, right? This is 19, and you're going to get how much divided by 10 to the power 4. Yes, into 10 to the power minus 64. Yes, whole to the power half will give you the O3. Yes, this is going to give you O3. Now can I say, children, square root of 64 is going to be half of this. If you take, it is going to be 32. Yes, it is going to be 32, and 32 is present only in one option. 32 is present only in one option. And what is that option, children? That is your option number 1, right? So you need not solve the entire thing. If you solve the power, you're getting this power only, and that is your this power. Yes, so that is going to be your answer. That is how you are supposed to solve it. Yes, okay, because I'm explaining you all these things, it is taking a lot of time, but if you are smart enough, okay, you can solve it within a minute. This should not take you more than a minute. Yes, okay, or like 45 to 50 seconds. Next question on your screen, and as you can see, this question is from Lee Chatlius principle. A hint for all of you. Okay, now again you need to pause the screen and try this question. Okay, children. So here I'll read the question, then I'll explain, then you have to solve it by yourself again. Which one of the following conditions will favor maximum formation of the product in the reaction? So when we are talking about the formation of product, yes, talking about the formation of products, then we are talking about forward reaction. Which reaction, children? We are talking about forward reaction. As in this question, we are given only about temperature and pressure. So we'll see what happens at equilibrium in case of temperature and in case of pressure. Yes. So you might be knowing that when you increase the pressure, the equilibrium will shift. In which direction? In that direction where there is less number of moles. Lesser number of moles of substance. Okay, where there are lesser number of moles of substance, right? Now, in case of pressure, in case of temperature, there are two types. One is your reaction is endothermic, and another is your reaction is exothermic. Okay, there are two conditions that you have to see. In case of endothermic, if you increase the temperature, your reaction will go in the forward direction. In case of exothermic, if you decrease the temperature, your reaction will go in forward direction. Or if you are increasing the temperature, your reaction is going to go in the backward direction. Yes, so these are the things that you need to know. Yes, these are the things that you need to know. And what are we going to discuss here then? We'll see what's given in the question for us. It's given that delta H is negative. So what is given to us here, children? The value of delta H is given to us as negative. When the value of delta H is negative, we see that this is an exothermic reaction. This is what reaction? Exothermic reaction. And you know, children, in case of exothermic reaction, when you want to take the reaction forward, you have to decrease the temperature. You have to decrease the temperature. That means a lower temperature. So wherever there are high temperature, that option is going to get cancelled. Yes. Now we'll see the number of moles for these are gaseous reactants. There are 2 moles, one in each case. Yes. And in the product, you are having 1 mole. Right. So lesser number of moles in the product side. So if you want to go towards lesser number of moles, which is itself in the product side, so you have to increase the pressure. So low pressure is not an option for us. So the only option available for us is option A. Yes, that is low temperature and high pressure. That is low temperature and high pressure. Understood, children? So what are we discussing here? We are discussing about Le Chatelier's principle in case of pressure and in case of temperature. So in case of pressure, when you increase the pressure, the equilibrium is always going to shift towards lesser number of moles. In case of temperature, endothermic, if you increase the temperature, it is going to shift in the forward direction. And if it is exothermic, you have to decrease the temperature if you want to move in the forward direction, right? Yes. So this was all about your Le Chatelier's principle, and these are the key concepts that you had to draw from this. Okay, moving on to the next question, children. Okay, so this is what I had discussed. This is just given here as point. So we'll just have a look at it. So when the forward reaction is exothermic, increasing the temperature decreases the value of equilibrium constant. Yes. When the forward reaction is endothermic, increasing the temperature increases the value of equilibrium constant. So that is what we just discussed. Yes. Okay. Now another question on your screen with another new concept. So just try it and let me know the answer. Until then, let me check if you're having any doubts and your responses as well. Okay, try it, everyone. Okay, children, let's see what's given in the question. Now, the equilibrium constants for following reactions are given. That is, for some reactions, the equilibrium constants are K1, K2, and K3. And you have to find out the equilibrium constant for the given reaction. Okay. Now, as we are discussing a new type of question here, we'll see what are the concepts related to it. Suppose I give you A plus B give rise to C is in equilibrium. Yes, is in equilibrium, and the equilibrium constant for the forward reaction is K1. It is going in this direction, the equilibrium, it is K1. Now what do? You are going to do the backward reaction, that is C give rise to A plus B. If it is something like this, okay, then this is just the reverse of the first reaction. That's why the new equilibrium constant is going to be 1 by K1. Okay, so when you do the reverse of the exact reaction, that is going to give you 1 by K1, right? So that is the first concept from here. Now let us look at the second concept, what it is going to say. Suppose A plus B give rise to C. Yes. Now what I do? I write 2A plus 2B give rise to 2C. So what I did is I multiplied with 2 in the above reaction. This is the same reaction. I just multiplied with 2, and suppose this is K1 is the equilibrium constant. So here the equilibrium constant is going to be, if you're multiplying with 2, so it is going to be K1 square. It is going to be K1 square. So if you multiply it with n, your new equilibrium constant is going to be K to the power n. Whatever you multiply, that goes in the power. Whatever you multiply, that goes in the power. Yes, so this is the key concept here. So what is the key concept here? That is, when going for the forward reaction, when you go in the forward reaction and your equilibrium constant is K1. For the reverse reaction, your equilibrium constant is 1 by K1. If you're multiplying, if you're having a equilibrium constant K and you multiply the equation with an integer, then the same integer goes on to the power. The same integer goes on to the power, right? So let us discuss what is being given here in this question. So we'll write all the equations that is given to us. And what is the equation, children? It is given us that N2 plus 3H2 give rise to 2NH3. Yes. K1 is given to us. Then we have N2 plus O2 give rise to 2NO. This is K2 here. Yes. Then what is the third reaction? H2 plus half O2. H2 plus half O2 give rise to H2O. That is your K3. Okay. These all things are given to us. Then you have to find out the equilibrium constant for the reaction 2NH3 plus 5 by 2 O2. 2NH3 plus 5 by 2 O2 give rise to 2NO. Okay, 2NO plus 3H2O plus 3H2O, right? So this is what you have to find out. Now see children, how are you going to approach this question? We see that NH3 and O2 are being added, right? But you see here NH3 was in which side children? NH3 was in the right hand side, but here it is in the left hand side. Here it is on the left hand side. So what are you going to do? You are going to reverse that equation, right? So what am I going to write here? I'll write 2NH3 N2 plus 3H2, right? And what is going to be the equilibrium constant? It is going to be 1 by K1. Yes. Now children, now I'll write N2 plus O2 give rise to 2NO, because I see 2NO is here, so I have to add this equation 2NO. So this is as it is, so this is K2, this is K2, right? And for the last reaction I see this is H2 plus half O2 give rise to H2O. I see that in the question it is 2H2O, but in the new equation it is 3H2O. In the new equation it is 3H2O. So what I did, I multiplied this entire equation with 3. Yes, this entire equation with 3. So this is going to be 3H2, 3 by 2, 3H2O. This is going to be K3 to the power 3. K3 to the power 3. Yes or no children? So now if I solve this entire equation, I see that I have 3H2 here, I have 3H2 here, so this both are going to get cancelled. Yes, so what is remaining for me? Now I see here is one N2 and here is one N2, so these both are also going to get cancelled. So what am I left with? I'm left with 2NH3. 1 O2 and 1, so 1 3 by 2. So 2 ones are 2 plus 3, so this is 5 by 2. O2 give rise to 2NO plus 3H2O. Yes, so when you are adding the equilibrium when you are adding this equation, so we added all these equations, right? We added all the equations. So when you add, these are going to get multiplied. So this will be K2 is getting multiplied with K3 cube divided by, this is K1 is below, so you write K1 below. Yeah, so this is going to be your equilibrium constant K. Yes, very, very important concept from here. Did you all understand children? What we understood, that when we are writing a reaction and when we do the reverse of that reaction, so what are we going to get? We get 1 by K. If we are multiplying something with the entire equation, we are going to get what? That as the power. And suppose we are adding the equations, so the equilibrium constant, they get multiplied here. Okay, so what is your answer? Where do you see this? You see it in option number 1. Yes, so I hope you all are noting it down and you can see this is your answer and your new concept is ready. Let us move on to the next question. Next question on your screen. You need to pause and try. Yes, okay. Okay, children, let us see. So what is given here? A 20-liter container at 400 Kelvin, yeah, contains CO2 at a pressure of 0.4 atm. So P1 is given to us as 0.4 and 20 liter. So V1, T1. The volume of container is now slowly decreased. So some volume has changed here. So V2. And we are asked also here the maximum volume when the pressure attains maximum value. The maximum volume when the pressure attains maximum value. So I can say that V2 is question mark. V2 is asked here. Okay. Then now what is being told to you here, children? Okay, the temperature has not been changed. The volume of the container is decreased now by moving the movable piston. Now the maximum value of the container when the pressure attains the maximum value. Now we know that we are being given SrCO3 SRO plus CO2. So in this reaction, your Kp, what is your Kp, children? It is going to be pressure of CO2. Why? Because these both are in solid state, so they are not going to be considered. And your maximum pressure is going to be at equilibrium. This is the important key point here. Your maximum pressure is going to be at equilibrium, maximum equilibrium, at equilibrium, right? So your pressure is going to be maximum at equilibrium. And now here P2 you got, your P2 is nothing but 1.6. P2 is nothing but 1.6. Yes or no, children? Now we know from the equation that PV is equal to nRT. PV is equal to nRT, right? Yes. Now, children, what happens? Initially, the things were not at equilibrium. Initially, the things were not at equilibrium, and also the container is sealed. The container was sealed, right? So one thing we got from here that n is constant. N is constant. The value of n is constant. Yes. So the value of n is constant means from here also I can find out the value of n. So we know that PV is equal to nRT. Yes. PV is equal to nRT. Yes. So if I want the value here, I can write 0.4 into 20 is equal to nRT, is equal to nRT, right? Okay. Now for the second case, children, the second case, we know that P into V, or this is P2 into V2 is equal to nRT, is equal to nRT. Now the value of n is not going to change, the value of R is not going to change, the value of T is also not going to change. Yes. So can I write, instead of P, the pressure has changed, that is 1.6, the volume is the new volume, nRT is nothing but 0.4 into 20, right? So the value of V is going to be 0.4 into 20 by 1.6. So this is 4 times and this will get cancelled and this is 5. So your answer is going to come as, 5. 5 liters is going to be your volume. So what was the key concept from here, children? So whenever it is sealed, okay, whenever it is sealed, the n is constant. The number of moles is constant, right? N is constant. Yes, n is constant. That you had to see. Yes. Okay. So let's see what's your answer. So answer is your 5 liters. Yes. And also the maximum pressure is at equilibrium. That's why Kp has the value of the pressure here, right? And also because the rest of the things, SrCO3 and SRO, these are in solid state. That's why your pressure was equal to Kp, which was your 1.6. Yes, good. Okay, now this is a easy one. Everyone try this based on whatever concept we read. Okay, so this is an easy question. Try this, everyone, and tell me which option is going to be correct. Okay, children. Okay, someone says option number 2. Let's check if it is option number 2. Option C. Okay, option C. Let us check. What is given? N2 plus O2 give rise to 2NO. So in the equation it is given to us N2 plus O2 give rise to 2NO. And what have we done here? Here we have done half N2 plus half O2 to NO, right? So what did we do here, children? How do you know what you have done? You see where 1 is there. Here 1 is there and here 1 is there. Here 2 is there. So when in such kind of questions, you see where 1 is there. So here 1 is there, here. How do you get 1 to 1 by 2? What do you multiply with 1 to get 1 by 2? You multiply half. That means here also to get 1 to 1 by 2, I have multiplied half. Here to get from 2 to 1, so I have multiplied with half. That is how 2 and half gets cancelled and you get 1 here, right? So you have multiplied half. So when you multiply something that goes on to the power. What did I tell you, children? When you multiply with n, it becomes k to the power n. It becomes k to the power n. Now tell me, children, what is going to be the answer? Whether it is option number C or it is option D. Whether it is option C or option D. It is going to be option D, right? So your correct answer is going to be option D, because whatever we multiply, that goes on to the power. Yes, whatever we multiply, that goes on to the power. Yes. Moving on to the next question, children. Everyone needs to pause it again, okay, and tell me the answer. Now, children, what is given here? It is given that if the value of equilibrium constant for a particular reaction is 1.6 into 10 to the power 12, the value is 1.6 into 10 to the power 12, means after 1.6 you are going to have 16 and 11 zeros, means it's a very huge number, right? Equilibrium constant is having a very large number. So when your equilibrium constant has a very large number, that means your reaction has proceeded. Your reaction has proceeded to give you products. Yes, good. The correct answer is A, right? When the equilibrium constant is very, very large, so you are going to have only products. You're going to have only products. And when it is very small, that means your reaction, when it is very, very small, your reaction is going to be just started. It has just started. So you'll have only reactants. When it is in intermediate values, then you are going to have both reactants and products. Means it's kind of in equilibrium, right? So here your answer is going to be mostly products. Good, good. Okay. Moving on to the next question. Now, let me see who is going to answer this. Okay. Okay, so let me read out the question for you here, children. What is given in the question here? Let's see what's given here, children. Now we are talking about an exothermic reaction. We are talking about an exothermic reaction. Yes. First thing is that. Now, it is telling that at T1, at temperature T1, you have Kp as the equilibrium constant. Yes. Then at temperature T2, you are having your equilibrium constant as Kp dash. Yes. This much is clear to us. assuming that the heat of reaction is constant in the temperature range. Heat of reaction is constant. Okay, your delta H. It is observed that it is readily observed that what is the relationship between Kp and Kp dash, that is asked to us. So how do we know? We know that there is a relationship between Kp and Kp dash in heat of the reaction. And what is that, children? That reaction is log of Kp dash by Kp is equal to minus delta H by 2.303 R 2.303 R 1 by T2 minus 1 by T1. Yes, this is our equation that we are going to use here. This is our equation that we are going to use here. Now we know that what is given to us here, exothermic reaction. Exothermic reaction means your delta H is negative here. Delta H is negative. Delta H is negative. Yes. Okay. Also, this is exothermic reaction. Means heat is liberated. You are getting more heat. Yes. So as you are getting more heat, so can I say that T2 is greater than T1? Like you had some heat. Now it is exothermic. So more heat is liberated. Okay. So you are getting more heat. Okay. So when you are getting more heat, so what happens? T2 is greater than T1, right? T2 is greater than T1. Yes or no, children? So T2 is greater than T1. So when T2 is greater than T1, so can I say that this part is going to be negative. This part is going to be negative. How, children? Suppose you see your T2 is greater than T1, then can I have here, suppose if I write 1 by 5 minus 1 by 4, for example. Okay. So when you get this answer, if you solve this is going to be 20, this is going to be 4, this is going to be 5. So you get minus 1 by 20. So we get minus 1 minus 1 by 20. So this is negative, right? So can I say that this part is negative here? So 1 by T2 minus 1 by T1 is what, children? Is negative. It is negative. Yes. So this much is clear to everyone. Now what we see, children, we'll erase all of this. Now we see, children, that this part, which part? This part is negative. Again, this part is also negative. So negative, negative, we got positive. Now, T2 is greater than T1. That's why this part is negative. When this part is negative, that means the entire from here to here, whatever you get, this is positive, this is negative. So this entire part is going to be negative. When this is negative, can I say that log Kp dash by Kp, whatever answer you get, you are going to get in negative. You're going to get in negative. Yes or no? Which implies I can write log Kp dash minus log Kp is negative. So when can you say that x minus y is negative? When can you say that? When y is bigger than x. When y is bigger than x. Yes or no, children? Then only you can say, right? Suppose here it is 5 and here it is 8. Then only we are going to get minus 3. If this was 8 and this was 5, then we would have got 3. Yes or no? So that's what I'm telling, that what are we talking about here? Here, from here we understood that your Kp, or we can say log Kp, is greater than log Kp dash, which implies Kp is greater than Kp dash. Kp is greater than Kp dash, which is in your first option. Yes, it is in first option. Good. Okay, good. That is going to be your first option, and I hope you understood that how it is solved. Yes, good. Yes, okay. Let us move on to the next question, children. Okay, so we have again seen that what Le-Chatelier's principle is and how does it work. So apply Le-Chatelier's principle here. Apply Le-Chatelier's principle here and tell me the answer. Okay, any answers, children? We have just discussed Lee-Chatelier principle. Okay. Now, I have told you in Lee-Chatelier principle, children. Now we'll see the equation here. What is given here, children? We see this is N2 plus 3H2 give rise to 2NH3. Give rise to 2NH3. This is our equation. Yes. And what have I told you, children? What have I told you? I have told you that there are two kinds of reaction. Now heat is evolved here. Heat is evolved here. So can I say this is an exothermic reaction? This is an exothermic reaction. Yes, this is an exothermic reaction. Now, as we are talking about concentration, we are talking about concentration here, pressure and temperature. Talking about concentration, pressure and temperature. So what happens when you increase the concentration? When you increase the concentration, Lee-Chatelier principle will try to okay. When you increase the concentration, what happens, children? When you increase the concentration, it will try to decrease. सोचो कि तुम लोग क्या कर रहे हो, कॉन्सेंट्रेशन बढ़ा रहे हो, कॉन्सेंट्रेशन बढ़ा रहे हो तो रिएक्शन ये करने का कोशिश करेगा, उस तरफ जाएगा जहां से तुम्हारा कॉन्सेंट्रेशन डिक्रीज हो जाए, जहां से तुम्हारा कॉन्सेंट्रेशन डिक्रीज। सोचो कि तुम ऐसे बैठे हो और तुम्हारे ऊपर और ज्यादा लोड दिया जाए, तो तुम क्या सोचोगे, ये लोड को कैसे हटा दूं मैं, ये लोड को कैसे हटा दूं। तो सोचो कि तुम यहाँ पे कॉन्सेंट्रेशन रिएक्टेंट में बढ़ा रहे हो। कितने मोल्स हैं बच्चा लोग यहाँ पे कितने हैं, यहाँ पे 4 मोल्स हैं, 4 मोल। तुमने क्या किया, और एक ऐड कर दिया, तो ये क्या सोचेगा, अरे भैया मेरा मोल्स बढ़ गया तो मैं इसको हटा दूं। मैं इसको कैसे हटा दूं, जब मेरे पास है तो मैं इस तरफ फेंक दूंगा, मतलब इस तरफ फेंक दूंगा तो बढ़ जाएगा, राइट। ओके, इस तरफ फेंक दूंगा तो ये बढ़ जाएगा, राइट। तो यहाँ पे क्या होगा, तुम लोग सोचो कि अरे मैं इस तरफ फेंक दूंगा। इस तरफ फेंक दूंगा का क्या मतलब है, तुम क्या कर रहे हो, रिएक्टेंट को प्रोडक्ट बना दे रहे हो, रिएक्टेंट को प्रोडक्ट बना दे रहे हो। मतलब अगर तुम कॉन्सेंट्रेशन बढ़ाओगे रिएक्टेंट की तरफ से, तुम्हारे पास ज्यादा प्रोडक्ट आएगा, क्योंकि अगर तुम रिएक्टेंट के ऊपर बोझ दे रहे हो तो वो सोचेगा मैं अपना बोझ हल्का कर लेता हूं, मैं अपना जो जितना बोझ मेरे को मिला है मैं वो प्रोडक्ट को दे दूंगा। ठीक है, तो कॉन्सेंट्रेशन अगर बढ़ाओगे तो रिएक्शन फॉरवर्ड डायरेक्शन में जाएगा, रिएक्शन फॉरवर्ड डायरेक्शन में जाना चाहिए। हमको क्या बोला जा रहा है यहाँ पे, हमको क्या बोला जा रहा है यहाँ पे, रिएक्शन शिफ्ट्स इन द फॉरवर्ड डायरेक्शन बाय इंक्रीजिंग द कॉन्सेंट्रेशन ऑफ NH3। अगर तुम NH3 बढ़ाओगे तो क्या रिएक्शन प्रोडक्ट की तरफ, रिएक्शन फॉरवर्ड डायरेक्शन में जाएगा? नहीं। तुम लोड, यहाँ पे क्वेश्चन में क्या बोल रहे हैं, हम NH3 का लोड बढ़ाएंगे, मतलब और NH3 इसको देते जाएंगे। NH3 सोचेगा अरे मेरे ऊपर तो तुमने लोड बढ़ा दिया, मैं क्या करूंगा, मैं रिएक्टेंट को दे देता हूँ, तो वो रिएक्शन बैकवर्ड डायरेक्शन में जाएगा, राइट। बाय डिक्रीजिंग द कॉन्सेंट्रेशन ऑफ N2 and H2, तो ये वाला ऑप्शन तो तुम लोगों का कैंसिल हो गया। बाय डिक्रीजिंग द कॉन्सेंट्रेशन ऑफ N2 and H2, तो हम लोग क्या बोले थे, लोड बढ़ाना है, लोड बढ़ाने पर वो राइट हैंड साइड में फेंक देगा, राइट। पर यहाँ पे तो बोल रहा है कि N2 और H2 का लोड घटा दो, यहाँ पे N2 और H2 का लोड घटा दो, तो यहाँ पे क्या हो जाएगा, लोड घटाने का बात कर रहा है तो ये वाला ऑप्शन भी कैंसिल हो जाएगा, राइट। और मैंने तुम लोगों को क्या बताया था बच्चा लोग, जब तुम लोग प्रेशर बढ़ाओगे, जब प्रेशर बढ़ाओगे रिएक्शन उस तरफ जाएगा जहां पे देयर इज लेसर नंबर ऑफ मोल्स, लेसर नंबर ऑफ मोल्स। ठीक है, क्या बताया था, रिएक्शन उस तरफ जाएगा जब तुम लोग प्रेशर को इंक्रीज करोगे वेयर देयर इज लेसर नंबर ऑफ मोल्स। और टेम्परेचर एक्सोथर्मिक के केस में, एक्सोथर्मिक के केस में जब तुम लोग टेम्परेचर डिक्रीज करोगे तब तुम्हारा रिएक्शन आगे जाएगा। एंडोथर्मिक के केस में जब टेम्परेचर बढ़ाओगे तब रिएक्शन आगे जाएगा, तब रिएक्शन आगे जाएगा, राइट। तो हम लोग यहाँ पे क्या देख रहे हैं बच्चा लोग, देखते हैं यहाँ पे तो बोला है N2 + 3H2 गिव राइज टू 2NH3, तो कहाँ पे कम नंबर ऑफ मोल से बच्चा लोग, यहाँ पे टोटल 4 है, यहाँ पे 2 है, यानी कि प्रोडक्ट साइड में कम नंबर ऑफ मोल से। तो अगर तुम प्रेशर बढ़ाओगे तभी ना प्रोडक्ट की तरफ जाएगा, तभी ना, मतलब क्या होगा, फॉरवर्ड डायरेक्शन में जाएगा। पर यहाँ पे तो डिक्रीजिंग प्रेशर बोला है, तो ये चीज भी नहीं होगा। तो क्या बोला है, इंक्रीज करेंगे प्रेशर, और क्योंकि एक्सोथर्मिक रिएक्शन है इसीलिए टेम्परेचर को क्या करेंगे, टेम्परेचर को हम लोग डिक्रीज करेंगे। टेम्परेचर को क्या करेंगे बच्चा लोग, वी आर गोइंग टू डिक्रीज इट, राइट चिल्ड्रन, वी आर गोइंग टू डिक्रीज द टेम्परेचर, राइट, यस। तो यहाँ पे हो जाएगा तुम्हारा ऑप्शन नंबर डी इज गोइंग टू बी द करेक्ट आंसर. ओके, यस yes, option number D is going to be your correct answer, and I hope everyone understood this. Yes, okay. अगला वाले में चलते हैं. ये वाला बताओ बच्चा लोग. ये वाला बहुत इजी है, दिखता मुश्किल है, सिर्फ नॉर्मल जनरल फॉर्मूला. ठीक है, जनरल फॉर्मूला होगा यहाँ पे, यूज करो इसको और बताओ क्या होगा आंसर यहाँ पे. ठीक है, तो यहाँ पे एक रिएक्शन दे रखा है हमको स्टार्टिंग से, विच इज A2 प्लस B2 गिव राइज टू 2AB. ठीक है, ये वाला रिएक्शन हमको दे रखा है. ठीक है, तो अभी ये बोला गया है एट इक्विलिब्रियम A2 का कॉन्सेंट्रेशन है 3.0 इंटू 10⁻³ B2 का दे रखा है 4.2 इंटू 10⁻³ और AB का दे रखा है 2.8 इंटू 10⁻³. ये सब प्रीवियस ईयर का क्वेश्चन आया गया है. ठीक है, मैंने कुछ ऐसा नया या इजी सा नहीं डाला है, एवरीथिंग हैज कम इन द प्रीवियस ईयर. ठीक है, तो KC का वैल्यू क्या होता है, यहाँ से तुमको एग्जामिनर ये बताना चाहता है कि तुम लोग पढ़ो, क्योंकि बेसिक से ही क्वेश्चन आएगा, तो इतना लोड लेने का जरूरत नहीं है. बेसिक सा टॉपिक, बेसिक सा कॉन्सेप्ट समझो और क्वेश्चन करने जाओ. राइट, ओके. तो यहाँ पे क्या हो जाएगा बच्चा लोग, लेट अस सी. AB का स्क्वायर, AB मतलब 2.8 इंटू 10⁻³ का स्क्वायर करना है यहाँ पे. A2 मतलब 3.0 इंटू 10⁻³ एंड B2 इज 4.2 इंटू 10⁻³. राइट, ये दिखता मुश्किल है पर इट इज नॉट डिफिकल्ट. राइट, कैसे, तो इसको हम लोग हटा देते हैं और देखते हैं क्या होता है यहाँ पे. तो ऊपर वाले को अगर हम लोग देखें, दिस इज 2.8 का होल स्क्वायर इंटू 10⁻⁻6 डिवाइडेड बाय 3.0 इंटू 4.2 इंटू 10⁻⁻6 -3 और -3, तो ये दोनों ये कैंसिल हो जाएंगे. राइट, ये दोनों क्या हो जाएंगे, कैंसिल हो जाएंगे. तो यहाँ पे आ जाएगा 2.8 इंटू 2.8 डिवाइडेड बाय 3.0 इंटू 4.2. ठीक है, इतना आ गया. यस, तो अगर हम लोग यहाँ पे देखें इतना, तो ये कैंसिल हो सकता है. दिस इज 2.1 एंड दिस इज 1.4. ठीक है, कैंसिल हो सकता है. फिर और भी कैंसिल हो सकता है. कैसे, 28 और 21 दिख रहा है, तो 7 का 0.4 टाइम्स, यहाँ पे 0.3 टाइम्स. राइट, यस, तो इतना हो गया. तो यहाँ पे क्या हो गया, 14 4 जा कितना हो जाएगा चलो 56. तो ये 0.56 डिवाइडेड बाय यहाँ पे क्या हो रहा है यहाँ पे 9. राइट, तो 0.9. तो ये क्या हो जाएगा बच्चे लोग, दिस इज गोइंग टू बी 5.6 डिवाइडेड बाय 9. इतना आ जाएगा. यस, तो ये 0.56 है, तो 9 6 क्या हो जाएगा 54 एंड 20. सो दिस इज 0.62. जिसने भी बोला है दैट इज करेक्ट. राइट, सो योर 0.62 इज द करेक्ट आंसर. ठीक है, तो ये वाला तुम लोगों का सही आंसर हो जाएगा 0.62. ठीक है, तो जो हमारा केमिकल इक्विलिब्रियम था, इसमें इतना कॉन्सेप्ट तुम लोग जान लोगे तो इट इज मोर देन इनफ फॉर यू. ठीक है, यहाँ पे एक और क्वेश्चन है. ओके, इसको देख लेना, ये तो मैं करवा देती हूँ. यहाँ पे देखो, यहाँ पे क्या दे रखा है, ये भी इजी सा क्वेश्चन है. यहाँ पे क्या बोला गया है, 2SO2 प्लस O2 गिव राइज टू 2SO3. ठीक है, तो यहाँ पे हमको क्या कर दिया है, यहाँ पे लिखा है SO3 गिव राइज टू SO2 प्लस हाफ O2. ये तुमको करना है. तो पहले तो क्या किया गया है, इस रिएक्शन का उल्टा कर दिया है. तो यहाँ पे अगर K1 है, यहाँ पे 1/K1 हो जाएगा, यहाँ पे 1/K1 हो जाएगा. इतना चीज तो हो जाएगा. फिर क्या गया है, देखो यहाँ पे 2 था, 2SO3 था, यहाँ पे सिर्फ SO3 है. यहाँ पे 1O2 था, यहाँ पे हाफ O2 है, मतलब यहाँ से आते वक्त हाफ से मल्टीप्लाई किया गया. हाफ से मल्टीप्लाई मतलब यहाँ पावर हाफ हो जाएगा, यहाँ पावर हाफ हो जाएगा. और यहाँ पे तुमको क्या वैल्यू दे रखा है, K1 का वैल्यू दे रखा है 278, क्या दे रखा है 278, राइट। तो तुम्हारा 1/K1 का वैल्यू क्या आ जाएगा, 1/K1 टू द पावर हाफ, तो क्या करोगे 1/278 टू द पावर हाफ, यानी कि यहाँ पे ये बताया जा रहा है रूट ओवर ऑफ 1/278 तुम लोगों को निकालना है, ठीक है। रूट ओवर ऑफ 1/278 तुम लोगों को निकालना है, तो इसको निकालो और मुझे आंसर बताना, ठीक है। तो इसका आंसर तुम लोगों का आ जाएगा 6.0 इंटू 10⁻², इसको सॉल्व कर लेना तुम लोग, ठीक है। ओके, तो आज के लिए इतना ही, और नेक्स्ट क्लास में हम लोग आयनिक इक्विलिब्रियम के बारे में देखेंगे, वहाँ पे बहुत सारा अच्छा अच्छा कॉन्सेप्ट्स और क्वेश्चंस है, उसको हम लोग डिस्कस करेंगे, ठीक है। तो अभी के लिए तुम लोग ये सारे कॉन्सेप्ट्स को अच्छे से रिवाइज करो, अच्छे से सॉल्व करना, एंड आई विल सी यू इन द नेक्स्ट क्लास चिल्ड्रन। बाय बाय एंड टेक केयर।